Moving on to the technical side of the program, our first session for the day is on areas of geoinformatics application in agriculture, and the session will be dealt by Dr. Debashish Chakravarti, who is the senior scientist at Summit. His expertise includes soil science, data analytics, and GIS. Dr. Debashish, these instructions are for you. You have a total of 45 minutes allotted for this session. I will be giving you two reminders, one after 25 minutes and another 35 minutes to help you keep track of time. I hope that is fine. Oh, you are good to start off with the session. Over to you. First reminder will come after 25 minutes.
Okay, thanks, Jinat. So, am I audible? Can you please confirm?
Yes, well and good.
Okay. So, it was my introduction, it was there, so I'm not repeating that. So, one thing is, Jinat, that this is our opening ceremony is over. I think if you can say that Mahesh and others who has come, they can leave if they have
Yes,
other engagements.
sure. So
I
I
have
was
I have seen one. Yeah, I have seen one resource person join, Dr. Priyabrata Sandra. He also can leave because they may be having other programs.
Yeah,
Because
let me make a quick announcement. I think Vivek, we are done. We can let Debashish present. We can let Debashish present his slide. Those who have joined for the opening ceremony, we have moved on to the technical sessions now, and we are starting off with the first technical sessions. So, if you have any work, not to the participant, the opening ceremony guest, you can carry on with your work, and we'll interact with you more in the coming days. Over to Debashish for the first session of the day.
okay, thanks, Jin. Yeah, just 1 minute. I'm sharing my presentation.
Sure.
Yeah, I could start. Okay, I think this is all. You can see my slides. Anyone can confirm it.
Yes. Can the participants also give a thumbs up in chats to let us know they all can see the presentation clear? Everyone, can you give a quick thumbs up in the chat? I don't see any thumbs up from the participant. Can all the participants see
Yeah,
the
I have seen.
presentation?
Isam has given a thumbs up.
All
Yeah,
right, all
Isam
right.
has given a thumbs up. So I will
Great,
go for
great.
it. Thank you.
Okay,
Thank you, Jila. Okay. So this is in brief of the geoinformatics applications. You people are aware of that one because it is not a new subject, and as well as even though you are not in that particular working with the remote sensing, GIS, geoinformatics, or any sort of this kind of thing, you must be aware of many of the applications which have been taking place in our days. In these days. So nowadays, without the geoinformatics, we are really not finding ourselves in a comfortable position. So many of the applications are invalid when you are not using the geoinformatics. So that's what you all know. So this is in brief of about the geoinformatics and some of the areas which I just tried to cover, which is under the umbrella, which is called it as agriculture applications. Because there are many, so I have only chosen 5 or 6 of the very important applications, and I try to give just a bit of the glimpses about the case studies, and so that at least you can have some ideas, and then you carry on with your literature scan to understand more. Okay, so I welcome you all. This is the first lecture, which will be only through the presentation. Rest of the things you will all have online sessions for your hands-on training. Okay, fine. So when you talk about the geoinformatics, there are many, you can say, many ambiguities that how this is being built up. So it's a, you can say, hybrid science where you have basically 4 components, and you all know that GIS, the Geographic Information System, is the very important. Okay, one thing I just pick, because these slides I put it in a you can say very simplified way, so that at least people who are at a very basic level, not having much idea about these things, can also be benefited. So please bear with me if you find that these things are very well known to all of you. So this geoinformatics, as I said, that it's having the 2 very core components. One is GIS, which is the basic analysis platform, And you have the remote sensing. So remote sensing is basically it's an information science, or it's having a tools, or you can say it's a data source. Anyway, whatever you can say. So when you talk about image processing, then it's a tool. When you talk about remote sensing data, it becomes a data source. GIS is basically a platform. It doesn't contain any data as such. You can take the data and analyze using the platform. GPS is basically giving the coordinates, and that's very important for the spatial analysis. You will learn more about that in the classes. And the database, obviously, we are talking about the spatial database, which is the core of this whole analysis. Whether it comes from remote sensing, whether it comes from any other sources, even though it is a point data, or even it's an Excel sheet also. So anything can be accommodated using the different kinds of understanding of that. So basically, there are 3 points which I tried to mention. It's having a spatial relationships, because whenever you are doing the analysis, it's very important for you to establish, which is very, very important, the relationships between features on Earth. Second is that when you have geographical data or any sort of spatial data and your application part, so it bridges the gap. So you are using the tools in order to generate. Suppose if you are doing some yield mapping, so you have the data with you, spatial and non-spatial data. Non-spatial means the tabular data, and then you want to use that one by your own software or your own understanding of the subject. So it bridges the gap. So you use the geoinformatics. The last one is that you have a range of activities, a huge plethora of different tools, technologies. It's you can say countless. You can have all modeling purposes, spatial analysis, modeling, information system, your cognition, different mobile company, everything is there. Everything comes under geoinformatics. Okay, fine. So when we say about the geoinformatics, basically we have mainly if you split this into geoinformatics, as you know, it's a geographical or geospatial data, whatever you say, and that's having 2 components. One is that the technology by which you are dealing with, and also the analysis part, which is the methodology. So both the things has to be very solid, very much understandable. Then only you can move forward and get your own you can say analysis results. Information science, as you know, that today's day, it is the important. You need to communicate them, and also using those communication systems into your own particular analysis platform, and doing this all sorts of analysis. So everything together gives your geoinformatics. When you say about the applications, so it comes from theory. Then it goes to geoinformation, your computation, technologies, and applications. So application is at the outer cell. So it is the outer cell, and theory comes first. So what I urge to use that here in this case, the theory is difficult for you to cover. You will get the hands-on training, the methodologies, the protocols, and how to deal with the data with the software. But try to understand why the things are happening. Because the theory part, if you are very much good at this, then you will have your own applications. Otherwise, you will only using the whatever is there, whatever is available. So you will not be able to have your own analysis system or your own analysis ideas if you are not follow with the theory part. So that's important. Next is that I am just giving you a brief understanding of the different components. As I said, the geographic information system. This is a very well known to, I think, many of you, that here we have many queries. I put it as where, what, why, how, and why do I care. All these things lead you to a kind of, you can say, intuition that you are doing some analysis by using the spatial data, which has spatial relationship among themselves. So it's a kind of that you are arranging everything under a sheet where all the objects or entities, whatever you are dealing with, so they are all interconnected. So you see this is very common, this, what is called that, can use my pointer, just one. So you see here that there is a different layers. So this is one very important concept of the GIS. I will cover a little bit more in my third deck lecture. So the layer concept is the fundamental of GIS. So your real world is being divided or sliced into different objects having a similar kind of characteristics. So you have the land, you have the elevations, you have different land parcels, use of the land, streets, custom, whatever. So you have a kind of homogeneous layering concept, and which builds your all layers, and stacking them together, you will get a real world. And basically, you have these two ways of analyzing or understanding rather your spatial data. One is called is a vector, another is called raster. And there is a simple difference is that this is made of small cells which are called pixels. This is called picture elements, and just like your any you can say digital image, and here you have only point lines and polygons by which you will be addressing one particular entity, or you will be mapping one particular entity or doing the analysis. Okay, this is the basic difference between these two. So most of the GIS nowadays are capable of handling the raster data to the very high extent. It was not earlier. Earlier GIS was capable of handling the vector data. So when the remote sensing starts coming in a huge way and you are getting all the data which are in the raster mode, so then your capabilities has to be increased. And now it is all that most of the cases you will get a remote sensing, because now the remote sensing is one of the very important resources of any data whichever you are asking. Now next comes remote sensing. And you know this is remote sensing, it is remote word is there, and you are sensing. So anything information you are sensing while not being in physical contact with that particular object. So you have to have a distance. So that's what you are using. You are using the electromagnetic spectrum. So the electromagnetic radiation, it is basically we are using more than 90% you are using the sun. And sun has got electromagnetic spectrum. And it's with a very low frequency, and it's with a very high frequency, it's with a very long wavelength to a very short wave. So we are not at this point capable of utilizing the whole spectrum. We are only utilizing a fraction of the spectrum, and often the most used is the visible spectrum. And nowadays, because of the vegetation, we are using the NIR spectrum. But the visible spectrum is, you can say, more than 70% of the use comes from the visible spectrum. But you have other spectrums, like say other energies in the microwave ranges, you have even radio wave ranges, and they have different applications. So when you talk about the natural resources management, so this comes the different satellites, as you all know. These are low flying satellites. Okay. And when you talk about the communication satellites, these are at the higher altitude. So all those are there when you are acquiring the information. So both the information you can use for your own idea, for own analysis. One hand you have the remote sensing satellites, and one hand you have the communication satellites. Both the things you are using for general purposes, we are mostly familiar with the remote sensing satellites. And this deals with these pictures which is there on the screen. And the map which I have produced, just to make you an idea that all those information need to be gathered, need to be put into some index or into certain form which you can compare or which you can have some sort of visualization. So the data comes in the digital, and it's a huge set of data. So you are trying to get some of the windows of the spectrum, some information which are very important for the specific object which you are looking at. And then all this information you are combining into an index just to have a comparison. So once you are mapping, you are comparing the things. You see here the vegetation, you find that most of the places in these parts in North Africa, this part in the West Asia, and then here this is all cold. And here you can find there is very less vegetation or no vegetation. And rest of the areas, like say even in Africa, we have got two distinct features. So there are all those areas which are very high vegetation. So in every case, you can find out that the NDVI map, and you see the values of the NDVI. So this way you can understand that where you have a good vegetation, where you have a low vegetation, or the vigors are different from one to another. Okay. So remote sensing, remember that it is both a tool and as well as a data source. And nowadays, for all of our cases, we are finding that the remote sensing is one of the most important data source for your GIS or the geoinformatics. Okay, now the next one is that your GPS, that is the what we call is that the global navigation satellite system. You all are familiar because everybody are using the mobile, and through the mobile using the GIS, using the Google Maps, you are going from one place to another. This everybody is using that. So basically, this is where you are getting or you are picking up the coordinates, and those coordinates are the location data. So once you are using the geoinformatics, you need to have two very broad data category. One is that you must have a geospatial location data, which tells you about where the object is located or the phenomenon is happening where. And the second one is the characteristics of that particular point. It could be the yield of a crop, it could be a soil particular pH, it could be a water availability of that particular region, and it could be anything. So that's a characteristic of the particular point. And that point you need to have a location. Without location, you cannot have a spatial analysis. That is the very simple understanding. So how the GPS works, I think many of you knows that it is through, you see here the very precise of the location of a particular point, and you find that here with the black dot only, you will be finding these are the two points where you see it can be anywhere located. So you need to have another fourth one. So there is a constellation of satellites because the satellites are all moving around and they will be taking up the location data. Once they are taking up the location data, it can be within that sphere everywhere in that particular boundary. So you need to fix up that one. So there is a mathematics involved. So you cannot have only one satellites which are tracking by your mobile. You have to have more than one. It will be 4 or it will be more than 4. So there is a 24 constellation of satellites. As you see that this is only the GPS is coordinating. And I just give you some of the pictures just for you to have an understanding of this. Now the spatial data, which is extremely important, and here we have, I just put it here, the ArcGIS, how they are using. So they are using the SQL language, which is a database language, and by which you are going to the geo databases. The geo tagging means that you have a location. So whatever the data you are tagging with a particular location, that's become a geo database. Okay, so please remember that. So in this case, you see all those table topology, polygon line points are only the it is the vector understanding of whether it's a point or it's a point joining 2 points at a line, 3 points are giving a curve, and then you have more than 3 points or 3 or more points, it's joining a polygon. So likewise, you are trying to understand the features where it is located, and then you try using the database in order to have your own analysis. Okay. So the fourth point is, so I mentioned you, one is GIS, that is the platform, Geographic Information Systems. And second one is your remote sensing. Remote sensing is specifically important because it has the most used data as on date. So you have the very huge volume of data for any applications, whatever you think. Yeah, of course, there are limitations, but I'm saying that those are available. The third one is goes the GPS. That's important for you to have a location data inbuilt in your computer system so that at least you can do all the analysis possible. And the last one is your spatial data or the geo database, which is the core of your all analysis. Now the application area, quickly I will finish that. Yeah, Gina, have I think 20 minutes of time or something, huh? So I will complete this. So a few applications areas. So one application is the precision farming, and that's probably the one area which has the maximum applications of the geo. Precision farming, the name suggests that you have a precision. So that means when you are having a farming, yes, please. Someone was speaking something? Oh, no. Okay. So precision farming is a farming which is being done by using geoinformatics to be in a broader sense, and also using the tools and technologies which are most advanced, most high-tech in order to do the farming in the most precise way. That means whenever we are doing a general farming, we are applying it in a gross scale. That means suppose we are applying fertilizer. You are applying on a gross some recommended fertilizer you are applying, irrespective of the soil, whatever the conditions it's having of the crop, you are just applying it randomly. Even if you are applying it in a band placement or some kind of those things, which is a precise fertilizer management, even then you are applying it in a gross manner. Because at some point you may have a high fertility, some point you may have a low fertility, or even the application of your pesticides. So if when applying the pesticide, it should be the where you have the most affected areas. So all these things require a very precise applications. And when you have a precise applications, you need to have a precise information of these particular things which are occurring there. And if you have to get that information, you need to have a high sophisticated gadget system, integrated them into, and then you will have the precision. So it is the precision farming is having a very huge, you can say, application part. It's people are using it in a different way. Someone is call it as precision farming, though it may not be precision farming, and someone is some part they are doing it in a very sophisticated, which may be possibly the normal farmers may not be adopting. So, but nevertheless, it is altogether giving you an idea of how to precisely monitor your crop, precisely have your inputs to the crops and your soil. So here you have most important is your collection of the data. So the more precise you are collecting the data, more you can interpret them, and then your application will be also very precise. So this is something which is at a research and development stage. It is not fully the package which is available, which you can take from one region to another. So it's all region specific, it's all crop specific, and it's all your what is called domain specific. Okay, but this is where the geoinformatics is applied the most. The second is that you have the crop condition assessment, and this is something which is being done not now, long back. Okay, since when do we have the remote sensing availability of the data, whether it's a coarse resolution or a fine resolution? So people have been doing this since long. And the one part I forgot to tell you that nowadays we have basically you can have two different levels of remote sensing acquisition of the data. One is at the satellite level. Okay, so satellite level is what you are seeing it from a very high, that is called spaceborne. And there are remote sensing application which is at a airborne, or which is near to the, you have seen the drones. And also there are low flying airplane where the image, where the sensors are there, and you can get it. So the advantage of the low flying aircraft or the drones is that you can have a more and more detailed information available from a particular field. The problem with the satellite is because as it is at a very high altitude, so it may not be able to look into that resolution. So the advantage part is that satellite, because it is taking your observations very frequently and in a, you can say, repeated manner, very regular, and also covering a large area. So earlier we didn't have much of these satellites data which is available at a finer resolution. Now even we can go for the remote sensing applications 10 meter or even less than that one. So those gives you an immense capability of applying to the agriculture field, because you know when you are applying to the agriculture field, you need to have a very specific. You cannot have a 1 kilometer resolution data or say several meter resolution data, 100 meter, 200 meter, because within that you will have so many different crop conditions, your different soil conditions like that. So you need to have very precise. So nowadays the remote sensing offering that one, and you will probably know many of the applications in these coming days. Okay, the one point I just want to mention is that you see these are the pictures which I have given you just to give you an idea. So it is see where you have two different times, and because of these conditions, because of the external conditions, you have different vegetation. As you can see in the left hand side there is a good vegetation, right hand side there is a less vegetation. How do you know? Because these are NDVI, so it may not be visible it much, but this is all the NDVI based on this one. So this is just a I'm giving that you are assessing the crop condition which was 1 year before and currently using the remote sensing. The most important part which I want to tell you is that you need to have an understanding of the basic theory of how it is operated. And that's probably the important part for you for your applications, because every time you cannot have the NDVI. So NDVI is the most used one. This is the crop condition assessment, but there are many other indices which are useful for your own application. So you see here, it's only the NDVI, and you can find out that I have mentioned the typical signature of a signature. Means it is just like it is capturing the information of crop, and then you can have, so in the x-axis you have all the spectrum, that is the your coming from the visible and you are going towards near infrared, because that's the part where you are mostly focusing on the vegetation, and you find that the peak one is a green vegetation and the lower one, the graph, is a non-healthy or poor vegetation curve. So these are the background, and then you are analyzing that one. So this is for one pixel, say for example, one particular spot in the field, and you are getting and you are segregating, accumulating them, integrating them over a plot or over a bigger one, and then you try to understand what is the crop condition. So this is one area which is very application of the geoinformatics. Crop yield prediction, and this is something which is an advanced stage. It is not only the geoinformatics as such using the remote sensing and GIS, but it also has to have other, like say simulation modeling, like say your machine learning. All those things are important, because yield prediction doesn't have only the crop condition assessment. It has also got other factors which are actually, you can say, accelerating the crop condition deterioration. Okay, so suppose if you have a prolonged dry spell, so how this crop condition is going to affect, and that only will affect the yield. So you have to have a weather forecasting, you have to have a field measurements which are very important, and you have to have a machine learning, because nowadays it will give you some more power to analyze the data which basically you may not be able to decipher. So you are using the machine learning. So crop yield prediction is one of the important areas of geoinformatics, but it is at a advanced stage. That means you need to take care of other important disciplines like say modeling, like say big data analysis. I have one or two more. So digital soil mapping now, I think those who are working on the soil particular, it's very important. Now, because of this, why is it important? Because we are, so far as we were doing the soil survey, and this soil survey is, I think I have, Jinat, I have how much time?
Vashish, we started. You have good 30 minutes in your hand to take the session, talk to people, get Q&A done.
Okay, good. Okay, thank you. So this digital soil mapping is one area which is very new, and this is because okay, let me explain this one a little bit. I have some time, so I will go a bit slow. So this is a typical digital soil mapping, and I have taken it from one of the paper which is authority. This is known as, you see here, there is McBurney, Alex McBurney. He is from the University of Sydney. He was, I think probably he was a dean before his retirement or so. He is a very, you can say, well-known scientist working in the digital soil mapping, and also this band, Budiman Minasni, and they are in a group. Budiman Minasani is actually what is called the support of this main group, and he is very thorough in all computer applications in this digital soil mapping. Okay, so this is from one of their paper. Here you find out that input data, you have spatial inference system, and then you have some so you have one spatial soil inference system, and another you have soil inference system. And step 4 is your digital soil assessment, as they have just what is called they has given this kind of a flow chart. It's a basic understanding. Coming from the first step, you have different soil observations. So what basically we have been doing in order to get all those step 2 and step 3, that we are going to the field like a survey, and we are digging the field, or you are taking some observations in the shallow depth or the deep depth, and you are analyzing in the field or observation either in situ or ex situ, whatever, and then you gather the data, and based on the data, you try to infer, like say sand, clay, what is the thickness of the soil, how it is the soil organic carbon, and all these things, available nitrogen, these things. Now, what happened is that, so this process is very labor intensive. This process is time consuming, and also you cannot cover a bigger area with your limited resources and time. So now they come forward with a unique concept that, okay, you have the observations in the field. Say, for example, you have several hectares which you have to map it of say certain aspect, whatever you do as a soil map of any characteristics or properties, and then you are taking the observations only. No, because there was a long there was a, you can say, a concept which is giving long back, that all the soil forming processes are responsible for a particular state of the soil. This is soil which you can find out in the field, which is a what is called result of many factors working together over several years. So this Budam Minasani and McBratney and et al., their group, they have taken this concept and they given the digital soil mapping using both your legacy soil data, that means which you are collecting from the field and also which you have collected earlier, tag them, geotagging them, and then taking other covariates. What are the covariates? That's exactly which I mentioned you, that all those factors which were responsible in terms of other entities in the field. Say, for example, you have a crop condition on a particular area which you are, so based on the crop condition, you have idea of the soil fertility also, because the crops may not be uniform over the whole field. Or say you have the elevation data with you, which is important for the water to be gathered at some point of time, or the fertilizer which you are using that can be washed away and accumulating at some part, and some part it will be deficient. And similarly, there are other covariates which you can bring with your soil data which you are having in order to have a map of a particular characteristic. So it basically gives you a scope of analyzing the limited soil data, plus using some other information which you can gather from other sources and other means, use them and get your soil data, soil map. So that is, you can say, improving the quality of your mapping, reduces the time consuming for getting of soil information or the soil samples collection from the fields and taking it to the lab and doing the analysis. And also it is because you are using the high-end computing system, so it is very fast, and then it will be, you can check this in between, just like you do in terms of data analysis or your other modeling. So this is one of the very important geoinformatics area which has come up, and it's a very new thing, and there is a lot of scope of working in this digital soil mapping. The next one is that we have irrigation management, and this one area which also takes care of the geoinformatics, but at the same time it will have your expertise or your understanding of other than the geoinformatics. That means the core data which you are using. Say, for example, I am giving you one very specific flowchart. You see here the mapping, that means your land use, land cover, and crop water requirement, which you can use the GIS and remote sensing. So crop water requirement, basically you have the evapotranspiration. The evapotranspiration is actually the particular plant, it is giving up water, and so that's something which is relates to the soil water availability as well. So the ET will give you, one hand it is the crop water demand, which is available, which is required, and at the same time it will give you that suppose you are applying the water, how much water is being used by the crop in order to produce a particular biomass or yield, grain yield. So if you go back, so tracing the ET or tracking the ET backwards, you will be having data on how the irrigation water is being used there. So you have a field, And in the field, you are monitoring the evapotranspiration, and you will be monitoring how the irrigation water is being utilized. So you are irrigating the plot, or if it is a rain-fed areas, then how the soil moisture is being utilized. So it's a back kind of propagation. So for this, you need to have a simulation models, because you know that when the crop water availability doesn't only depend as the water available, it also depends on the soil properties. It also depends on the roots through over which it is extended, because it depends from one crop to another, their root proliferation, their root anatomy, and at the same time, it will also have different typical soil characteristics by which the water is being available to the plant, plus the weather. So if it is a very hot weather condition, if it is a humid, the evapotranspiration will be reduced. If it is a hot but it's a very dry, evapotranspiration will be increased if the soil water is available. So there are many factors which are operating. So that's why you need some sort of modeling. And then you have irrigation systems, because where you are giving the irrigation, which areas are being irrigated, what are the different forms of irrigation, that also you need to take into consideration. So there, as it's a special kind of, you can say, special kind of analysis, so you are using the geoinformatics. So you see here, it is a Idaho in US. So here it's a plot, and they have just taken one snap of a particular area, and you will find that there is a evapotranspiration between April to October. The total evapotranspiration was they have given. So the evapotranspiration, so you see it is varying. So you can observe the color region, so it's varying. So some places it is high, some places it is low. So that means the utilization of the irrigation is different. So if you have between April to October, this is the cumulative evapotranspiration. So that gives you an idea of how much the irrigation water is being used. Suppose you are applying all irrigation water uniformly, so that means there is some issue in that one, whether why some irrigation water has not been used, why the ET is not to that extent which is happening in other places, but here it is less. So as I'm saying, you are going to the back propagation kind of thing. So using the satellite data, you are trying to get the ET, and now you are transforming it into irrigation management. So this way the geoinformatics also have been used. And as I told that here also you have to have many other collateral data or many other covariates which will be used for irrigation systems management or irrigation management. Okay. I think, yeah, this is the last one. And this is what I have done during my PhD. This is not my work. But this is where I started application of this one by when you can say the resolution of the satellites was very coarse, and then I had to buy some good resolution satellites. Now this scenario has changed completely. So there are series of satellites which are there in the space. You can use them without spending any money. Only you have to have a system to support that. That's all. So now it was not there when I was doing my PhD. So I had to buy some good resolution software in order to do. So what this is all about? So this is about the soil erosion of a particular area. You are mapping that. So you are mapping different areas where you are expecting or you are estimating there could be more erosion and there could be less erosion based on a very basic soil erosion formula or soil erosion, you can say basic concept. That soil erosion is a cumulative effect of many factors. You have here the rainfall erosivity, that means how much rainfall is there, which is known as rainfall erosivity. You are analyzing which is your annual rainfall data. You are analyzing the soil, whether the soil is more prone to erosion, because it's not that everywhere the soil will be prone to erosion. This also depends on how much silt content, how much sand content, how much clay content, whether there is organic matter good or bad, whether the soil is having a good depth or it is having a shallow depth, all those things are there. So everything analyzed, you will get a soil erodibility. So these are the two things. One is rain erosivity, that means how much erosive is the rain, there is very high intensive rainfall or low intensive rainfall. Soil, whether the soil will be washed away very quickly or it has got some resistance. This is two things. And then there are two important is one is that whether there is a crop cover or not, what is the assessment, whether the crop is there, and second is that what kind of practices you are being taken. Suppose you are already doing some good management practices there, some conservation practices there, whether so those areas definitely will have less impact of the rain, so less erosion will take place. So what geoinformatics does is that it gives you a room where you can take everything and then you decide which way you integrate them based on the basic theory. So the basic theory says that once you are having a soil erosion prediction, you will have these are the factors. How you will get all the factors data? You use the geoinformatics, you use the different data sources, bring into your computer system, try to do the analysis in a spatial manner, and then you bring this particular map, which gives you a, a decision making ability that okay, these areas where you have a low erosion, like say blue areas, and this moderate is the green areas, and high are all reddish areas. All those things you need to take care. So that means for this particular watershed or some basin area or your own farm area, so you are having different areas of the different, you can say different your involvement of your resources, because resources are always limited. So if you have some resources, you use it for the most prone areas. So geoinformatics gives you that ability. Yeah, I think I can stop here. And if you have any questions, this is an overview of the geoinformatics. Overview of some of the very important areas I just covered. There is many more. So, and you may be doing those things nowadays, or you will be doing after this training session is over. Okay, so I invite any queries, anything, whatever, because we still have, I think, 10 minutes.
We have good 10 minutes to take
10
Q&A.
minutes.
All those who want to ask a question to Debashish are kindly requested to switch on their cameras, please, so that we know who's asking. And I think Debashish, given the time, we can accommodate 2 to 3 questions max, so that we can move on to the next.
Please pause.
Anyone would like to ask anything, any comment, anything that was unclear, anything that you find interesting, anything from your end?
Screen is very small. Could you please make large?
Sorry?
Yeah, Nakibullah is giving me chat.
Sangeeta, are you trying to ask something?
Yes, ma'am.
Sangeeta,
Am I
please go.
audible, ma'am?
You're audible.
Yes, sir. Okay, sir, the lecture was very informative, and especially in the application aspect, I have one query. This crop yield prediction, which you had means mentioned, as you say that we need weather forecasting data, some field data, and also machine learning aspect is involved in this crop yield prediction. Sir, can you please mention which of the machine learning tools may be used in this to get the crop yield prediction?
Okay.
Any specific tools?
Yeah. Okay. Thank you, Sangeeta. This is a good question, but it's difficult to answer. The difficult because see nowadays machine learning is an area which is evolving very quickly, and so you will be getting more and more algorithms, more and more different machine learning techniques which are available nowadays. So most of us has known, like say a random forest, we know the QBIS model, we know some gradient boosting, all those things. Those are very common in using that one. So what I suggest you is that each machine learning has their own advantage, disadvantage. It is just like a particular person's intelligence. Okay. So suppose if you 5 persons are working in a particular field, but intelligence, dedication are different from one person to another. And as this is true, then your outputs are also going to vary. So similarly, when the machine learning, because this is machine learning is something which we only have created by our own understanding. And some machine learning can support some of the analysis, which may not support some of the different kinds of analysis, different kinds of data system. Okay. So all 5 people have their different intelligence, different dedication. Similarly, when you are using one machine learning, it may be good for a particular set of analysis, but may not be good for another set of analysis. It all depends on the data. whether the data is having any trained or whether they are not having any trained, whether the data comes from one single source or whether data coming from multiple sources, whether the data at what resolution you are talking about, whether it can, this machine learning can also take care of you can say, or different sources of the data together. So all those things are very important. So I suggest you, because it's a huge subject, if you are doing it of your own, take machine learning languages as much as possible. That means, suppose if you are taking 4 or 5 machine learning which are very common, which many people are used, that's the most common use. Take them and then get your own results and use the statistics in order to know that which machine learning is giving you the best result. Okay, there are statistics, all the general statistics you all know, that R square, RMSE, bias and everything, and you come to a particular, there are procedures by which all those parameters, statistical parameters you use and come into one index, and you compare the index among the machine learning you have used and pick up that one, because then you are almost true to your analysis. Okay, because you may not understand that what is the limitations of machine learning always. That's the limitations for our part, because we are not a hardcore computer specialist. Okay, and even a hardcore computer specialist may not understand your subject. So it is better use a statistical way to decide which algorithm you use. And trust me, most of the machine learnings which are having very close, they will not differ much. If you have for one particular picked up, you see the second and third are very close. So they will not differ much.